Hello everyone, I hope that you're doing great. Now today we're looking at this 2023 BGCSE Physics Paper 1. Please remember before you start the examination, write the school number, your candidate number, your surname, and initials. Also, please read through the instructions carefully to ensure that you understand each instruction. And if you should have any questions or queries, please clarify them with your examiner. Let us jump into question number 1 at this time. And question number 1 reads, a book at rest on a table is given a horizontal push as shown in the diagram. Which force will cause the book to slow down to a stop? And that force will be frictional force. For number 2, it said which is a weight is an example of which quantity, and weight is definitely a force. For question number 3, it's a spring has a original length of 2 centimeters, so pay attention to that original length of the spring. The graph shows the extension of the spring when various weights are attached. It said on the graph, what is the length of the spring when 4 newtons weight is attached? And so please make the note right here now that 4 newton weight will cause an extension of 20 centimeters. So they ask us for the length, the total length at 4 newtons. And so therefore for working, it will be 2 centimeters, which is the original length, plus the 20 centimeters extension. And so therefore the answer is 22 centimeters. And so therefore D is the correct answer. For question number 4, it's if 4 divers, A, B, C, and D explore the coral reefs in the ocean, which diver will experience the greatest pressure? And this will be diver C, simply because pressure increases with depth. For question number 5, it said which graph shows the relationship between volume and pressure of a gas while temperature is constant, and that is Boyle's law. All right, and simple Boyle's law state that for fixed temperature, then volume and pressure are inversely related. Simple mean as you increase pressure, the volume of the gas will decrease. Hence, B is the correct answer. For question number 6, it said 2 forces, 20 newtons and 5 newtons act on a 5 kg box, which is on a frictional less surface. It said the direction of the forces are shown in the diagram. And so if you notice that the 20 newtons is going towards the left, 5 newtons is going towards the right, and the box is 5 kg. It said, what is the acceleration of the 5 kg box? And so as we know that force is equal to mass times acceleration, therefore acceleration is force divided by mass. However, to determine the total force or the net force, all right, as the 20 newtons and the 5 newtons are in opposite direction, so therefore means then the force equals to 20 newtons minus 5 newtons, which gives us a net force of 50 newtons. Therefore, the acceleration is going to be 15 newtons divided by 5 kg, which is the mass, and that equals to 3 meters per second squared. So therefore, B is the correct answer. For question number 7, it said what type of energy does a stretch elastic band contain? And that will be a potential energy. Remember that kinetic energy is in motion. Chemical energy will be stored in chemicals, such as in batteries. And light can never be the answer for that one, as you know. For question number 8, is a diagram shows a stationary car in a parking lot. All right, so notice that the car is 12,000 newtons, and then we have the reactional forces from the tires. And so this read now, we said that the car has a weight of 12,000 newton. It said equal and opposite reaction forces on the road pushes upwards on each of the 4 tires of the car. Well, 4 wheels of the car. It said, which is the correct reaction force on each wheel and the law of motion being demonstrated. So looking at the force on each wheel, and there are 4 tires or 4 wheels. And so therefore this will be 3,000 newton. Why? Because we divided 12 by 4. So we get 3,000 newtons on each wheel. And this is the 3rd law of motion. And simply because, of course, we know that forces act on each other in opposite direction, but they're also equal, right? Or in a simple way, to every action, there's an equal and opposite reaction. All right, that's a simple way to state Newton's 3rd law. So if you notice that the weight, just go back a little bit, notice the weight is going down, and the reactional forces, they are going upwards. All right. So the forces are equal in the total forces, total upward forces, they're equal to the total downward force. And of course, again, as stated, they're in opposite direction. All right. For question number 9, is a steel ball is dropped from a height of 4 meters and it falls under the influence of gravity. Air resistance is negligible, and that means that air resistance has no effect on the overall mass of the ball. All right, or even any force, really. That's what they're saying. All right, it said, what is the ball acceleration and velocity as it falls? And so the acceleration will be constant because it will be under gravity, and that will be about 9.8 or 10 meters per second squared. And of course, the velocity will be increasing because again, the change in velocity will give us the acceleration. If the velocity is constant, then there will be no acceleration. All right. All right. Now for question number 10, it said 4 distance time graphs for 4 cars A, B, C, and D are shown below. All right, it said which distance time graph shows the motion of a car moving at constant velocity away from its starting point. And again, this is very important to say this is distance time graph, all right, not velocity time graph. So don't be confused with that or make a mistake, right? So let's show you the 4 graphs now. And if you look at them carefully, all right, for B graph, it is showing you that it's constant. That means every change in distance is equal, well, every change in distance is given equivalent amount of increase in time. And so therefore it will be a constant velocity. So B has to be the correct answer. For graph A, this will be at rest because the distance is not changing regardless of a change in time. So this car will be at rest. All right, and of course, this will kind of be a constant, even though this kind of going up, and then, all right, well, I wouldn't really say constant, but increase really in velocity, and then you have a decrease or reverse because going back to the original distance, so that will be like a reverse. All right, and then for this D, it will be a constant or increase, and then you come to a stop eventually. All right, for question number 11, all right, this diagram shows 3 spheres made of cork, wood, and aluminum, and placed in a container of water. And so we have the cork, wood, and aluminum in different jars in water. And they said now which substance is the most dense, and they're referring to out of the 3 the 3 substances or 3 materials. And just to make note, this will be aluminum. Aluminum is one that is actually sinking to the bottom. All right, this diagram is should show the aluminum at the bottom because otherwise water could be the answer. All right, but it is going down to the bottom. All right, based on this diagram. All right, so A is the correct answer for that one. Number 12, it said, which is a third class lever? And I just kind of make a little notation right here, FLE. And FLE kind of tell you the class of lever. Any of these, once they're in the middle, then that determines the type of lever. For example, F represents fulcrum. So if fulcrum is in the middle, then that's a first class. If the load, L is load. So if load is in the middle, then that is a second class. And if the effort, E is effort, if effort is in the middle, then that is a third class. And so the only one that is shown here is ice tongue, because remember, if you look at the tongue, the end part is the fulcrum. The next end is we pick up the ice. So that is the load right there. And you put your hands or fingers in the middle, and that will be effort. Effort in the middle, then that is a third class. Seesaw and scissors, they are first class. Wheelbarrow, which is a load in the middle, then that is a second class. For question number 13, it said the pulley system shown is used to lift 100 Newton weight. It said if the weight of the lower pulley and friction are ignored, what is the mechanical advantage of the system? All right, I notice we have 3 pulleys right here, and also we have 3 different attachment of forces pulling on each pulley. So each rope is very important right there. So this will be 3. So the mechanical advantage is 3, simply because 1 pulley equals to a mechanical advantage of 1. All right. And so again, just to make a note, that mechanical advantage equal to the number of pulleys that you may have. All right, or mechanical advantage equal to the number of ropes supporting the load. All right, and if you notice, attaching to the pulley, we have 3 segments of rope right there. And so therefore, or mechanical advantage is 3. For question number 14 is an object traveling with an initial velocity of 5 meters per second undergoes an acceleration of 2 meters per second squared. What is the velocity after 3 seconds? All right, and just as working, we know that acceleration is equal to v minus u over t. All right, so therefore v is equal to u plus at, and u is the initial velocity, v is the final velocity. All right, and so therefore v, which is the final velocity, equals to 5, and 5, which is initial velocity right here, all right, plus 2 times 3, all right, and so 2 is the acceleration and 3 is the time, and so therefore it will be 5 plus 6, which equals to 11 meters per second. For question number 15, this one reads now, the diagram shows a demonstration of a law in physics. All right, so notice the coin is on the paper is pulled, and the coin will fall into the cup or into the glass. It says which law is demonstrated in the diagram, and this is Newton's third law. All right, and say, notice here now, so the coin stays at rest until it moves. This is actually first law. So the coin stays at rest until it moves by the force of gravity. Once you move the paper, all right, now inertia decreases, and then it will fall due to gravity. All right, so that's Newton's first law. External force is required to move the object, and that, in this case, gravity is the external force. Now, for question number 16, is a student attach a deflated balloon to the mouth of a glass bottle and alternatively place it in a cold and hot water bath or bath. It's a diagram shows the results in the cold water and hot water. All right, so what's going to happen here now, if you notice in the cold water, the balloon is still inflated, deflated, I should say, and then in the hot water, the balloon will inflate. So it said, how does the kinetic theory or kinetic energy of the gas molecules compare to the average distance between gas molecules in the balloon in cold and hot water? All right, and so the kinetic energy of gas, just to make mention here, it's more in hot water bath for sure. So we know that definitely will be one of the options. And of course, A is a less in cold water bath, which is perfect. However, now what makes a difference? Average distance between the gases will have to be more in the hot water. So we have more energy in hot water, and also we have the particles will be at further distance from each other. So therefore, C is correct answer for that one. For question number 17, it's a cube of length 4 centimeters placed on a top hand balance to measure its mass, as shown in the diagram. All right, it said what is the density of the cube? And so first and foremost, let's look at the volume. If one side is 4 centimeters and it's a cube, then all sides are equal. So the volume will be 4 times 4 times 4, which equals to 64 centimeters cube. Now the mass here is 500 grams, as you see right there. And so for the density now will be, so the density here will be the mass over the volume, and the mass here is 500 as we see on the scale, and then the volume is 64 centimeters cubed, so therefore this 7.8125 grams per centimeters cube, and so therefore A is the correct answer as a round off volume. All right. Question number 18 is an alcohol base hand sanitizer rubbed on the hands feel cool. It's a which process explains this cooling effect, and this will be evaporation, because once you evaporate anything, it takes heat away. The same thing when you sweat and the sweat is evaporated, it takes heat away from your body. All right. So C is the correct answer for 18. 19 is a few drops of colored liquid dye are added to water in a conical flask. Is that the results of the 3 and 6 minutes are shown, and so you notice the drop of in the flask, right? The color dye in the flask, and then after 6 minutes, you notice that it spread out. And it said which process is occurring in the conical flask, and that is definitely diffusion. Particles move from an area of high concentration to a lower concentration until evenly distributed. So eventually, the flask will be filled with the colored ink. All right, our colored dye. Now for 20, it said which is the main energy transformation taking place in microphone And in microphone, you have kinetic energy because when you speak is vibration, and then it converts into electrical energy. So movement by vibration, which is kinetic, and then it moves to electrical. All right, number 21. It said, what is the kinetic energy of a 25 kg cart that is traveling with a velocity of 16 meters per second? And as we know, that kinetic energy is equal to half mass multiplied by velocity squared. And therefore, we're going to have half of 25, which is the mass, and then multiply that by 16 squared, which is the velocity. So we're going to have 12.5 multiplied by 256, and that equals to 3,200 joules. Therefore, C is the correct answer. For question number 22, which quantities are measured in the same unit? And definitely here, it said measured in the same unit, or measured in the same unit. Where I put energy, Okay, yeah, this is correct. Right, yeah, that's why I like this, because it said energy and work, definitely, but not power. Because power is measured in watt. Energy and work, they're measured in joules. All right. Energy, work, and power, no, because again, power should be not included in this. All right, so C is the correct answer, not power. That's very important. All right, this is the reason why I like this, because this almost play trick on my mind as well. All right, so energy and work, they're the same, but not power. Power is wattage, while energy and work, they're in joules. Now, question number 23. An ice cube at temperature 0 degrees Celsius is put into a drink at a temperature of 10 degrees Celsius. After a short time, some of the ice has melted and the drink has cooled to a temperature of 8 degrees Celsius. What is the temperature of the remaining ice? So the remaining ice, even though here they said the cube of ice was 0 degrees Celsius and put in that drink of 10 degrees Celsius, yes, the drink changes to 8 degrees Celsius, which means the drink is cooling. But the question I ask here, what is the temperature of the remaining ice? And the remaining ice has to be 0 degrees Celsius because it is still ice, right? And ice will remain at temperature until after melting. All right, as the ice melts, it's the same 0, but after a while, after melting, then definitely it starts to increase. All right, for 24, is that which process involves the displacement of the entire medium? And this is definitely convection. All right, we know conduction is us passing through heat through the substance, but convection, for example, in water boiling, the entire water will start to move. The particles going up and down. All right, evaporation, only part of the particles move, and the particles will escape at the surface of the liquid. So only those at the surface will actually start to move. All right, and definitely not radiation. For 25, we said which phenomenon occurs as light passes through a lens, and this will be refraction for sure. All right, and refraction is when light bend from one medium, and this is referring to light because not just light, but any waves. All right, so this is bending when traveling from one medium to another. In this case, it's light. All right, of course, diffraction, just to make note of that, diffraction is the spreading of the light or wave, spreading out of the wave or light in this case around corners or through slits. Refraction occurs in sound and not in light. All right, and of course, reflection forms images and occur in mirrors. All right. 26 is the diagram shows a wave, is which labeled distance is the amplitude, and that is definitely A. As you know, B is half of a wavelength because a wavelength should carry you from the distance between two consecutive points. All right, and so C could be a wavelength and D could be a wavelength, but B will be like half of that wavelength because if it at the end of the crest, then it should go continue to the next end of the other crest, which is over this point if you could see my pointer. All right, so A is the correct answer for amplitude, is the height of a crest or the depth of a trough. Now 27 is which property is unique to electromagnetic waves? And it's a move parallel that is sound wave requires a medium to propagate that's a sound wave as well. And so C is the correct answer. It travels at the speed of light. Definitely all electromagnetic waves, they travel at the speed of light. And of course, travel at the speed of sound, which is foolishness because sound is not a member of the electromagnetic waves. All right, 28 is which combination of colored light can produce white light, and that definitely is blue and yellow. All right, so A is the correct answer for that one. Question number 29 is a ship uses a device to determine the depth of the seabed. The device emits a sound pulse from the ship, which is reflected at the seabed to the receiver on the ship. So I want you to notice that this impulse will go down and come back up. So just to note this, because that's very important. Is if the pulse is received 0.4 seconds after transmission and the speed of sound is 1,500 meters per second, what is the depth of the seabed? So notice take 4 seconds to leave the ship, go to the seabed and return. That's what this 0.4 seconds is. So please note that the 0.4 second is the time to hit the seabed and return. That means twice the distance, right? And so the time to hit the seabed from the device is 0.4 divided by 2, which is half of that, which is 0.2. And so therefore, we remember that velocity is equal to distance over time. Hence, distance equal to velocity multiplied by time. Therefore, distance equal to 1,500 multiplied by 0.2, which equals to 300 meters. So therefore, B is the correct answer. So pay attention to the details in the question before you start your working, okay? Question number 30. It says diagram shows a lava lamp. When the lamp at the base is switched on, wax droplets, commonly referred to as lava, rise in the lamp. All right, and so notice we have the lava droplet right here. And so the question now is said, what is the correct change of volume and density of the wax droplet? All right, and so again, what happened here, because of the heat that is applied, then definitely the wax droplet will increase in volume. All right, and then the density will decrease, and that's why we have floating taking place. If the density increases, then what's going to happen? It's going to sink. All right, so it can float because the density is becoming less and less as the volume increases. The particles are spreading out due to heat. Now, question number 31, it said, which quantity will increase as the amplitude of a sound wave increased? And that will be energy. All right, and also note that loudness increased as well, because amplitude affects the loudness of a sound and definitely energy. All right, frequency is affects pitch. All right. Now 32 is which rule describes two characteristics of a light wave, and light can never be longitudinal, so anything with longitudinal will be out. Light is an example of a transverse wave. All right, it is also electromagnetic as well. So therefore, B is the correct answer. It's both electromagnetic and transverse. It's not mechanical. Mechanical waves examples will be like sound and water waves. All right. All right, because of course, because of vibration is like a mechanical movement of something. All right, and water waves, because you have ripples and so on. Yeah, then those are mechanical waves. Now for 33, it's a light waves pass from air into glass and are refracted. It said what always remain constant when this happen, and that frequency, because the frequency is how the wave is being propagated. All right, or how fast the wave is propagated. So that is not changing, but what may change will be direction may change, speed may change, and also wavelength. All right, because those things will change based on the medium. All right. So let's jump into question number 34. Question number 34 says a diagram presents a converging lens forming an image of an object. It says which distance is the focal length of the lens, and this is definitely from the center of the lens to where you have the intersection of the refracted ray. All right, and so therefore from Q to R is the correct answer. So QR is the correct answer. Now 35, you say a diagram shows a wave fronts of light waves leaving air and entering a glass block. All right, so if you notice the air and notice the glass block, notice that it actually changed in direction because refraction is taking place, two different medium of optical different densities. It's which describes the process occurring and shows the effect on the speed and frequency of the light wave. And so the process we know that is going to be refraction, all right, and so only C and D could actually be correct here. But however, the speed will decrease as it's moved from air into glass, because glass will be of a greater density and it will decrease. All right, the frequency again remains the same because it's propagating at the same rate. All right, so the way that you cause or create the wave will be the same. That remains. All right, and so C is the correct answer for that one. For question number 36, it says 4 wires are made from the same material. All right, it says which wire has the least resistance? And so the least resistance, if a wire is thicker or shorter, then those things will have less resistance. Longer wires and thin wires, they have more resistance. So therefore, the thickness, the thicker one, which would be 0.4 in this case, either C or D. However, the shorter one, which is 100, and therefore C is the correct answer for that one. 37, this diagram shows a circuit with a 4 ohms resistor. All right, so notice the 4 ohm resistor right here. We have A, which will be the ammeter, and we have V represents the voltmeter, and voltmeter is saying 6 volts. It said if the voltage across the resistor is 6 volts, what is the current flowing in the circuit? And so we know that V is equal to I times R, so voltage is equal to current times resistor or resistance. And so therefore we know that current, which is I, equals to V divided by R, and so therefore I is equal to 6, all right, which is the 6 volts divided by the 4 ohms, which equals to 1.5 amperes. All right, so therefore B is the correct answer. 38 is a water heater has a power consumption of 3 kilowatts. It said if it uses this power on an average of 3 hours per day, what is its average daily energy consumption in joules? And so we know that power is equal to energy divided by time. And so therefore, all right, energy divided by time, that's what power is. And so therefore, energy, if you want to find energy, it equals the power times time. However, there's some special notation right here to make, is that the power, which is 3 kilowatt, is the same thing as 3,000 watt. Time is in 3 hours. It's the same thing. If you multiply 3 by 60 by 60, then you get 10,800 seconds. So therefore, it will be the power, which is 3,000 multiplied by the time, which is 10,800 seconds. So therefore, what we're going to get right here, we are going to get, this is what, 3,240,000. All right. And so that will be our, no, that's actually 32 millions, 400,000. Yes, so 32,400,000. All right, awesome. That's the amount of joules that we're going to get, right? That's the energy. So D is the correct answer. All right. And for 39, they said, what is the electrical safety device in the household that uses an electromagnet? And that definitely is a circuit breaker. All right. And so A is the correct answer. For 40, it says a steel bar can be magnetized by stroking it with a bar magnet, as shown in the diagram. The steel bar is being stroked in an anti-clockwise direction. All right. So it said, now which row indicates the magnetic pole indicated at the ends A and B for the steel bar? All right. And if you're stroking with the north pole going this way, then A has to be north and then B will be south. And simply because when you carry the north all the way down here, south will be stopping right here. All right. The north will, of course, be repelling and go away from the north, but the south will continue traveling along with the north pole of the magnet. So keep on going that direction. At the end right here will always be south. All right, remember south, opposite poles will be attracting each other. All right. All right, so B is the correct answer for that one. For 41, it's a magnet can be used to induce a voltage into a coil of wire. The needles of the galvanometer, let me just come over a little bit more. Yeah, so the needle of the galvanometer moves to the left when the south pole of the magnet is withdrawn from the coil. So please make a note right here. Now we move this left. All right, so the galvanometer deflect towards the left. But why it does this is when you withdraw the coil from it. So that's very important to note when you're withdrawing the coil, the magnet from the coil. So notice this now. We said that which row best explains what will be seen in the galvanometer if the poles of a magnet is reversed and move towards, this is very important, move towards the coil at a faster rate. Now, the thing is this. We know that if you switch around the poles, the deflection will be the opposite way, okay? So the idea is, if you switch around the magnetic pole, but you see in the first scenario, they see a move towards the left, all right, which means you're coming this way. So, and then you withdraw it. So the deflection is towards the left, and that occurs when you're withdrawing the magnet. So therefore means now, if a switch pole is around and withdraw the magnet, then we shift towards the right. But so notice a key word here. It said you reverse the poles, but you move the magnet. You move it towards the coil. You're going towards the coil. So if you're going towards the coil, what's going to happen? It will be in the same direction. All right? Because remember, if you're putting this magnet as it's shown here with the south pole this way, then this was going towards the right. Okay? But now if you put the switch poles around and you push it in still, then they're going to go the opposite way, which is towards the left. So we're looking here will be left and will increase because faster movement or faster insertion and removal of the magnet in the coil will give you a greater, faster deflection. All right, so the answer here is B. All right, and simply because it's reversed, but you're going towards. All right, which will be opposite to the scenario that is shown. 42. Is a stable atom of carbon has 6 protons and 6 neutrons. What is the number of neutrons in an atom of carbon which has a mass of 14? All right, so a mass number of 14. Now we know that mass is equal to protons plus neutrons. So therefore, neutrons equal to mass minus proton. And so therefore, if the mass is 14 and the neutron is still 6 because the neutron is not changing, all right, and this is case an explanation of isotope. And so therefore, it will be, the neutron will be 8. All right, so we have 8 neutrons within that carbon. For 43, it said, what is the process occurring in the core of the sun which produces heat and light, and that is nuclear fusion? Just make a note of that. All right, and for 44, it said 100 grams of a radioactive sample is present when a stopwatch is started. After 30 minutes, 25 grams of a sample remains. What is the half-life of a substance? So we know if you have 25 remains after 30 minutes, then this is what happened here. This is a scenario. You move from 100 grams into 50 grams, that's half-life. They move from 50 grams and 25 grams at another half-life. So therefore, we know we have 2 half-lives. The entire thing took 30 minutes. So if it's 2 half-life, we divide the 30 by 2. So each half-life will be 15 minutes. So the half-life here is 15 minutes. Now for 45, is a food processing company uses radioisotopes, which can emit particles or rays to improve the shelf life of foods. Which particle or ray more suitable for this process? And this will be gamma ray. And there are a number of reasons why gamma ray is used. One of the main ones you'll believe is safety. It is generally safe. Not only that, it has a great penetrating power. All right, you can produce it at a low cost compared to the others, and it also kills microbes. And once you kill the microbes, then that will increase the shelf life of the food. All right, for 46, it said which is the unit used to measure electromotive force, which is EMF, and that is volts. All right, so EMF and potential difference, they measure in the same unit. 47, which tests could be used to find out which end of the magnet is a north pole, and that is definitely put it near a compass. Put it near the first metal will not tell you which pole it is. It just be attracting the metal. That's all what happen. Put it near a non-ferrous magnet, a non-ferrous metal. Definitely no attraction at all. All right, it'll be no attraction because the non-ferrous material means that it cannot be magnetized. Put it near a steel spoon. It will be just like B. They attract to the magnet, but you can't tell you what pole is what. 48, it said the velocity time graph below shows the motion of 2 friends, Paul and Mary, while jogging. All right, so if you notice that Paul is on a stationary or constant velocity, while Mary was bolting, she was increasing, she was accelerating, and then she comes to a point where she starts maintaining that speed. But Mary outdid Paul. All right, it said which row best describes the motion of Paul and Mary between 60 and 120 seconds. So 120 is right here. All right, so this is where she was starting from this point to where here, but Paul maintains the velocity. So therefore, for Paul's motion is a constant velocity, but Mary, constant acceleration. So these are the correct answer. For 49, it said, which of the following would have the shortest wavelength? And in this case, you have infrared, we have light rays, and light rays definitely will be the shortest one right there. We have sound and water. Last question is an unloaded truck of mass 2,500 kg, all right, travels at a steady speed of 20 meters per second. It said the truck then picks up 2,500 kg of cargo and travel with a steady speed of 15 meters per second. Now, the axis here is what is the momentum of the unloaded and loaded truck? Now, remember that momentum is equal to mass times velocity, right? So the momentum of the unloaded truck here is 20, which is the velocity multiplied by its mass right here, which is 2,500. That gives us 50,000. All right. And that will be 50,000 kg meters per second. And then the loaded truck now will be 2,500 plus the 2,500 of the original weight of a truck. So notice cargo here is 2,500, and the loaded truck with the cargo here is 2,005. So that's going to be 5,000 multiplied by 15 give you 75,000. All right, a point to note here is that the momentum of the loaded truck. So notice they have the unloaded truck on this side, the loaded truck on this side. So be careful because sometimes you calculate them and realize that they switch it up in the chart. So this is loaded side and this is the unloaded side. So therefore, what we're going to have here is 7,500 for the loaded side. And then for the unloaded side, it is 50,000. So therefore, C is the correct answer. All right, and that's the end of the review. Thank you for watching. Good luck on the examination and talk to you soon.